All right. Mary will do today's. Get comfortable. You can set your book down, whatever you want to do. But talk us through.
Yeah. So this one's 13, and so 13 equals a squared root of 3, and then this one's a, this one's 2a, and so then to solve this, you have to like divide off the square root of 3, and so then you just have 13 over square root of 3 equals a, and then you can multiply by square root of 3, so it's 13 square root of 3 over 3 equals a. And so then this side is 13 square root of 3 over 3, and this side, since it's 2 times that, it's just 26. Okay, so this one, I think, you divide it, but when you take off the 360, and then
Yeah, you're good. So we wanted to be in the same position. So she went back one full rotation. She went back 360 degrees.
and so then 160, and so that could be the positive one, and then for the other one, do you add it?
Well, we want a negative one now, right?
Yeah.
I'm
so
almost.
Wait. You do yeah. So then you do 360 minus the 160. Then it's 200. So then you have positive 200. Or wait, negative 200 positive.
So now pause for a second, because you're right. You did end up with the right number, but then you magically made it negative.
Yeah.
So pause for a second. Let's think about it. You're at 160. Now you want to go to a negative number, right?
Oh, so you subtract.
So subtract 360 again, right? And that's how you get the negative 200.
Okay.
Right? Any multiple of 360 added to or subtracted from your original angle, and you'll get the ones that you want. Any multiple. So another option for this one would have been, instead of subtracting 360 to get positive 160, she could have added, right? That would have been another option. Okay, so keep on going. You're good.
So this one's 73 because there's 73 until you get to like the 90. And this one, you can subtract 360 first. So it's 153. And then you could just do 180 minus 153. That's 27.
The only thing I'm going to be nitpicky about is I don't see any notation on any of those numbers, and they are all talking about.
Oh.
So add that in. Add in the notation on each of them.
Oh, degree.
Mm-hmm. And it's going to be important with notation because we're going to be talking about degrees, and then we're also going to be talking about something called radians, which we haven't learned yet. So there's going to be two ones, and we need to make sure that we know how to represent both. Nice job, Mary. So, today will be pretty quick because we only have one more skill to cover in 13.2. And the one thing I would tell you is that next Wednesday or Thursday, depends how we do, tomorrow, Monday, and Tuesday, Wednesday or Thursday next week, we'll have an assessment. And it's going to be on 3 sections. 13.1, 13.2, which we're finishing up today, and then Friday, Monday, we're going to cover 13.3, right? And depending on how long 13.3 takes us, maybe we'll also spend Tuesday and then review Wednesday and then test Thursday. Or maybe we'll just test Wednesday. Depends how we're doing. But Wednesday or Thursday of next week, you'll have an assessment. 13.1, you shouldn't feel too stressed out because was 13.1 very difficult? Well, somebody recall, what was 13.1? Sine, cosine, tangent, cosecant, secant, cotangent. This one we're almost done with. It's up on the board what we did, coterminal angles, reference angles, angles of rotation, and today we're going to evaluate trig functions given a point. So, let's see. Probably actually just want to get this down. This is what is going to be important. You want to have this diagram, and you want to have this to go with it. They are not on Schoology, no. This is so important, I want you to copy it down, right? Copy it down by hand. It's not really pertinent right now. I'm taking notes. Oh, I was talking to somebody else. No. Okay. Well, what's highlighted? This and this. These two go together. Some of your classmates who have a hard time seeing, they take a picture and they write it down. So you copy it down and we'll talk about it. It'll make sense once we do a couple examples. So if you have a hard time seeing, I'm just going to name off some of the things that are on here. You have the xy plane. You have a point, x comma y, on the terminal side of this angle. Okay, here's the terminal side. Here's the initial side. Here's the angle theta. When we use trig functions, we can only use them with what kind of triangles? Right triangles, right? So that's why we are talking about these things called reference angles, which you see right here. You see how they're creating this triangle right here? That's going to allow us to do trigonometry, all right, using this reference angle. Well, it turns out that if you want to take sine of that big angle, theta, all you have to do is take the y value of your point, divide it by, what is r representing? What is r representing? R. What is the square root of x squared plus y squared? It's here. It's here. R is representing what? Hypotenuse, right? It's representing the hypotenuse of this triangle. Here's the x value, if you look at it as a triangle. Here's the y value, if you look at it as a triangle. Well, what's the length of this? Square root of x squared plus y squared, right? That gives you the hypotenuse. Yep. Because if we look at it as a triangle, right, we need to say they're positive. But that's just if we're looking at it as a triangle, right? This tells me the x value. This tells me the y value. So I can look at it as a triangle. Okay. This point? We're going to actually try it. So it's good to ask these questions. Well, if you notice, sine is going to be y value over radius, or hypotenuse. Cosine, x value over radius. Tangent is going to be y over x. And let's go to the picture and find out why. If you look at this as a triangle, and you look at the reference angle, what's opposite to this angle? Okay, what's the hypotenuse? So what's the sine of the angle? It would be opposite over hypotenuse, which is y over r. Okay? What's the opposite? Y. What's the hypotenuse? R. So sine of that angle would be y over r. This is using our reference angle. Well, what would be cosine? Cosine of this angle would be adjacent over hypotenuse. X over r. Tangent, opposite over adjacent. Y over x. Do you see where all these are coming from? Yes.
So what's the part of it?
You're trying to find, I'm going to ask you, for example, just this. I'm going to ask you, what's tangent of this theta? Sometimes in pre-calculus and calculus, you're going to be interested in those values for this angle. So, that's why. Carol?
So if it's like just like absolute value of y and x, when you put those into the sine cosine stuff, should it be absolute
That's,
value?
recognize that's only when we're talking about a triangle.
Oh,
That's only to help us. We don't, tell you the truth, we don't even need to really worry about that because what are we doing with the x and y here? Squaring them. So it's kind of excessive. Notice, are there absolute values down here? So could some of these numbers be negative? Yes. Okay? Practice. I know it's a lot to take in when you look at it, but let's practice to make sense of it. So here's one example we're going to do. I want you to draw the xy plane and plot the point. Draw the xy plane and plot the point. There's your point P. There's your terminal side, or your vector. And now where's your angle? Your angle is right here, right? This is theta. This is theta. All right. Well, to be able to answer what is cosine of theta, sine of theta, blah, 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 we need to find out one number that we don't know yet. R. So let's find out what R is. R is equal to square root of x squared plus y squared. Well, that's square root of 6 squared plus 9 squared. 36 and 81 give me 117. Great, so now I know R. R, the radius or the hypotenuse, is square root 117. Now I have everything I need to answer the questions like what's sine of theta? Well, let's see. Sine of theta is, recall what it was, what over what? Right? It is opposite over hypotenuse, but in this scenario, y over r. So my y value is a positive 9. My r is a square root 117. I don't leave it like this. I have to do what Mary did earlier. Rationalize the denominator to get 9 root 117 divided by 117. Yep.
So how? I just don't get why you're finding the sine and cosine of an angle that's not in the triangle.
Again, you cannot do trigonometry on angles that aren't acute. we had to use a reference angle. And what you're just being asked to believe right now is that if you want to take sine of this angle right here, all you have to do is look at this triangle, right, which we set up to find this r, all right? We just say what's opposite over hypotenuse, we say what's adjacent over hypotenuse. It turns out that those things are going to be exactly what we want. Sine of theta will be opposite over hypotenuse. Cosine of theta will be adjacent over hypotenuse. Tangent of theta will be opposite over adjacent. Y over x.
So, are you doing it for the theta or for the
This
angle
is
of
all-
the triangle?
This is all for theta. Okay? This is what you have to know. Cosine of theta. I'm not asking you guys to believe too much, all right? Cosine of theta. It was x over r. X value is negative 6 over square root 117. Negative 6 root 117 over 117. There you go.
Would it be a positive 6 because it had the
Go back up here.
did it not
No absolute value. You take the
Oh.
x value.
okay.
So just use exactly what you're given. Tan of theta. Tan of theta. That should be y over x. So what was that? That is a positive 9 over negative 6. And you're right, that should be negative 3 halves. Good? We're not done yet because we asked for all 6. So let's go back. Sine is related to which one? Cosecant of theta. Well, cosecant of theta is just what? It's just the reciprocal, right? Cosecant of theta is just reciprocal of this, so isn't it just r over y, right? Square root 117 over 9.
So do you do it for instance?
Well, look, if you were to have done this one and then flipped it, you would have had to rationalize the denominator and you would have got back here. So why not choose this one? So when you take the reciprocal, because they're all equal, and so you don't have to rationalize again. I saved myself a step, right? Okay, so what's secant of theta? Secant of theta? Square root 117 over negative 6. There you go. Cotangent of theta? Well, yeah, but let's do reduce, right? It's negative 6 over 9, but let's just say it's negative 2 over 3. So do what's easiest, right? I already have them reduced, so might as well use them. If I do this one, I would have had to do more work to get back to here. If I use this one, I would have had to do more work to get back to here. If I use this one, I would have to reduce, right? So choose what's easiest. If you've already done the work. Good? Need to ask questions while we're going through this. Okay? Well, let's try one more time because we're only learning one skill today. So try one more time with this one. And actually, let's do one where we have two negative numbers. So instead of negative 3, 6, let's do point negative 3, negative 6. Okay? Two negative numbers. First, let's ask ourselves, what's theta? What's theta? Just so we have a picture of what theta is. Is it this space here, or is it this space? Do we go counterclockwise, or do we go clockwise? counterclockwise. So theta is this. We're talking about this space right here. Okay? Always, when we're talking about rotating, right? We're talking about going counterclockwise, unless I tell you that we're going in a negative direction. Okay? All right, so now let's answer these. Somebody find out for me what r is. Okay, r is square root of what? 45. 45 can be reduced. Square root of 45 is the same thing as what? Nope, you pull out a 9. 3 square roots of 5. Yep. Well, what axis is this? X. Which one is this? Okay, so this one must be my, yep. So it helps to label and to get an idea of what these things are. Here's my X. Here's my Y. All right, and now I can do this. Let's see, sine of theta. Sine of theta, that should be y over radius. Well, what's my y? -6. So it's -6 over my radius, which is 3 roots 5. Let's simplify the -6 and the 3 first. -6 divided by 3 gives me -2 over square root of 5. If you simplify that one, there you go. Okay, so there's that. Cosecant would be easy to find right now, so you tell me what that is. Negative square root of 5 over 2. Yep. Does everybody see how we found that value? Cosecant is just the reciprocal of sine, right? So I just took this value here and I flipped it. How about this one? Cosine of theta. What was my x value again? -3. What was my radius? 3 root 5, right? This is on your paper, so I should hear more than just a couple people. Well, let's simplify with the 3's first. 3 divided by 3. So -1 over root 5. If you rationalize the denominator, you get a negative root 5 over. Okay, so if you're getting lost, you need to ask. Secant would be easy to find right now. What's secant? A negative square root of 5 over 1, or if we just write it nice and easier, negative square root 5. If you're lost or something, let me know. Tangent. Tangent's nice because we don't have any square roots. Tangent, is it going to be positive or negative? Positive, what's it going to be? Let's look back. Y over x, so it's going to be a positive 2. What's cotangent? There you go. You got this? Yeah. If there's anything you're confused about, let me know, because I'm going to ask you to do a CFU right now. So, is there anything you want to ask about before you do it on your own? Okay, there you go. So, hop to it. You got a 6-question CFU. 6 questions. There you go. It's a good head start. Well, yep, today's just practice, so you have homework. Yes. Yep. This is just today and yesterday's.